As of today, March 4th, 2026, the eyes of the world are fixed on a new date for humanity's return to the lunar vicinity. The next major milestone in NASA's ambitious Artemis program, the crewed Artemis 2 mission, is now scheduled to launch no earlier than April 2026. This adjustment is not merely a small shift on a calendar, but a reflection of the intricate and demanding nature of deep space exploration. The decision to postpone the mission came after a series of technical challenges surfaced, prompting NASA to reevaluate the immediate launch schedule and the entire strategic sequence of missions leading up to the first lunar landing. This revised timeline represents a deliberate, safety-conscious approach. The path forward has been clarified, providing a new roadmap for the coming years. The initial plan has evolved, shaped by the realities of developing and testing next-generation spaceflight hardware. The changes affect the roles of several upcoming missions, pushing the historic return of astronauts to the lunar surface to a later date while adding crucial testing phases to mitigate risks. This careful restructuring is designed to build a more robust and sustainable presence on and around the Moon. The primary reason for the revised Artemis schedule stems from recent technical issues discovered during preparations for the Artemis 2 launch. The mission was originally slated for a March 2026 launch window, but a cascade of challenges forced a postponement. The first significant problem identified was a liquid hydrogen leak. This type of issue is a persistent concern in rocketry, as liquid hydrogen is an extremely cold and tiny molecule, making it notoriously difficult to contain. Even a minor leak in the propellant system can pose a serious safety risk and requires meticulous inspection and repair, a process that consumes valuable time and resources, ultimately impacting the launch schedule. Following the work to address the hydrogen leak, a second, unrelated issue emerged. Mission controllers detected a problem with the helium flow to the rocket's upper stage. Helium plays a critical role in the propulsion system, where it is used to pressurize the fuel tanks and ensure a steady flow of propellant to the engines. In response to the helium flow issue, NASA made the difficult but necessary decision to roll the entire SLS rocket and Orion spacecraft stack back to the Vehicle Assembly Building on February 25, 2026. This massive undertaking, using the powerful Crawler Transporter 2, moved the vehicle from the launch pad back into the controlled environment of the VAB. A rollback is a major logistical operation that signifies a delay of weeks, if not months. Inside the VAB, engineers and technicians have better access to the hardware to troubleshoot the problem, conduct thorough diagnostics, and implement the required repairs to the helium system on the rocket's upper stage. While the rollback officially closed the door on the March launch window, it was a proactive step to ensure the vehicle's integrity and the crew's safety. NASA's ground teams have been working diligently to diagnose and resolve the issue as quickly as possible. The agency has stated that these swift preparations may allow them to preserve the April 2026 launch window. This conditional timeline depends entirely on the successful completion of the repairs and subsequent testing. The delay underscores a fundamental principle of human spaceflight. The launch schedule is always dictated by the readiness of the hardware, not the other way around. The journey of Artemis is as much about the engineering and operational hurdles overcome on the ground as it is about the flight through space. The new timeline, therefore, is not a setback, but a carefully plotted course correction, ensuring the program is on the firmest possible footing as it reaches for the Moon once more. This essay will explain the series of events that led to the new timeline, breaking down the specific issues, mission changes, and strategic decisions that are reshaping the Artemis program. Awaiting their historic flight, the crew of Artemis 2 represents a blend of veteran spaceflyers and a new international partner, poised to become the first humans to travel to the Moon's vicinity in this century. Reed Wiseman, Mission Commander; Victor Glover, Pilot; Christina Koch, Mission Specialist; Jeremy Hansen, Canadian Space Agency Mission Specialist. Their mission is a pivotal flight, pushing the Orion spacecraft's capabilities. Validating life support systems with a human crew on a deep space trajectory. Artemis 2's mission profile is a lunar flyby, using a free return trajectory around the Moon. The moon's gravity will sling the spacecraft back toward Earth, without a major engine burn to start the return. That gives the mission a built-in safety advantage, ideal for the first crewed test flight. On an approximately 10-day mission, they'll travel farther from Earth than any human has gone before, venture beyond the moon's far side, loop back for a high-speed re-entry, and splash down in the Pacific Ocean. In one of the most significant updates to the program, NASA has fundamentally changed the objective of the Artemis 3 mission. Originally planned as the mission that would return American astronauts to the lunar surface, Artemis 3 will now serve a different but equally critical purpose. The mission has been redesignated as an Advanced Earth Orbit Test mission. Instead of traveling all the way to the moon, the Artemis 3 crew will launch into space and remain in Earth's orbit. This pivot responds to delays in commercial lander development and lets NASA run more thorough tests in a simpler environment. The new focus will be practicing and perfecting rendezvous practicing and perfecting docking with the Lunar Landing System. The Human Landing System. Astronauts will fly the Orion spacecraft to meet a commercially developed lander in low Earth orbit. This gives the crew a first chance to interact with the lander hardware in space. Testing navigation interfaces, testing communication interfaces, testing docking interfaces. Alongside the specific mission changes, NASA announced a broader restructuring of the Artemis program on February 27, 2026, aimed at increasing the frequency of missions and establishing a more sustainable and predictable rhythm of exploration. This new strategy, referred to as an accelerated mission cadence, is designed to build momentum and achieve the national objective of not just returning to the moon, but creating an enduring human presence there. A key element of this plan is to standardize the vehicle configuration for the SLS rocket and the Orion spacecraft to streamline production, reduce costs, and shorten the time between launches. A significant addition to the manifest is a new mission planned for 2027. This flight will serve as another opportunity for astronauts to test critical systems in space. The crew on this mission will dock with one or more of the new commercial moon landers while in low Earth orbit. This will allow for detailed, hands-on tests of the lander's navigation, communications, propulsion, and life support systems. The ultimate goal is a steady cadence of at least one crewed surface landing every year following the first successful landing. To support this goal, NASA is embracing a dual lander strategy, SpaceX Starship HLS and Blue Origin Blue Moon, providing redundancy, competition, and innovation. With annual missions, infrastructure can grow, habitats, power systems, and mobility platforms, for a sustained human presence. This steady rhythm is essential for learning how to live and work on another world, a crucial step toward future human missions to Mars and beyond. With the reprofiling of Artemis III, the historic honor of being the first crewed lunar landing mission since Apollo 17 now falls to Artemis 4. According to the updated timeline announced by NASA, this landmark mission is now targeted for early 2028. This flight will carry astronauts to lunar orbit, where they will board a pre-positioned human landing system and descend to the surface near the moon's south pole. This region is of immense scientific interest due to the presence of water ice in permanently shadowed craters, a resource that could potentially be used for life support and rocket propellant in the future. The year 2028 is shaping up to be a remarkably ambitious one for NASA's lunar ambitions. The agency is not just planning for one landing, but is aiming for two. Following Artemis 4, NASA hopes to launch Artemis 5 later that same year, which would also include a crewed landing on the moon. Achieving 2 lunar landings in a single year would be an unprecedented feat. This ambitious goal depends on the maturation and availability of commercial lunar landers, SpaceX and Blue Origin. A critical aspect of the preparations for Artemis II has been the intense scrutiny of the Orion spacecraft's heat shield. The heat shield is an absolutely essential component responsible for protecting the crew from the extreme temperatures of re-entry, which can reach nearly 5,000 degrees Fahrenheit as the capsule plummets through Earth's atmosphere. following the uncrewed Artemis mission analysis revealed that the heat shield experienced more charring and erosion of its ablative material than engineers had anticipated. This discovery triggered a thorough review and a vigorous debate within the agency about whether the heat shield was safe to fly with a crew. The debate centered on whether the existing heat shield design provided a sufficient margin of safety for the Artemis II crew, or if a redesign was necessary. In January 2026, after intensive review, Administrator Jared Isaacman announced support for proceeding with the existing heat shield, citing additional data and testing that addressed many questions, while acknowledging some continued objections. A significant development shaping the current direction of the Artemis program is the change in leadership at the very top of NASA. On December 17, 2025, the United States Senate formally confirmed Jared Isaacman as the 15th Administrator of the National Aeronautics and Space Administration. Nominated by the President earlier that month, Isaacman brings a unique background rooted in the world of commercial spaceflight and entrepreneurship. His appointment signals a continued emphasis on public-private partnerships. Isaacman is perhaps best known as the commander of Inspiration 4, the world's first all-civilian mission to orbit the Earth. He personally financed and led that mission in 2021. That mission flew on a SpaceX Dragon spacecraft and marked a major milestone showing space was becoming more accessible. His experience as a pilot, entrepreneur, private astronaut, one of Isaacman's first major decisions as administrator was to weigh in on the critical Artemis II heat shield debate. After conducting a deep dive into the technical data and meeting with the relevant engineering teams and external advisors, he made the call to proceed with the mission using the existing heat shield, balancing technical risk with programmatic schedule. His hands-on approach sets the tone as NASA integrates SLS and Orion with fast-moving commercial partners like SpaceX and Blue Origin. The updated Artemis timeline with its delays and mission changes may initially appear to be a setback. However, a closer look reveals a program adapting to challenges with a calm, measured approach. The decision to postpone Artemis II to April 2026, the shift of Artemis III to an Earth orbit test, and the retargeting of the first landing for 2028 are not signs of failure. Instead, they represent a mature and responsible strategy that prioritizes crew safety and mission success over adherence to an arbitrary schedule. The road to the moon is fraught with immense technical complexity, and these adjustments are a natural part of the process. Each delay is an opportunity to learn and improve. The liquid hydrogen leak and the helium flow issue that prompted the Artemis II rollback are valuable lessons that will make future launch campaigns smoother and more reliable. The extensive debate over the Orion heat shield, while contentious, ensured that every possible risk was thoroughly examined. Similarly, repurposing Artemis III as a rendezvous and docking test in Earth orbit is a prudent step that will significantly lower the risk of the first lunar landing attempt. The future of the Artemis program, while now set on a slightly longer timeline, appears more robust and sustainable than ever before. With this steady and focused work, NASA and its partners are paving a safe and sustainable road back to the moon and beyond.